Hello everybody and welcome back to our game engines class. In this unit, actually in the next couple of series, what we are going to do is to wrap up our work with the Ogre 3D in terms of learning how to make your applications interactive so that you could interact with user through mouse or keyboard, and also about animation in Ogre. And then we move on to the Unreal Engine. In this lecture, particularly, what we're going to do is we are going to look at user inputs and learn about the concepts of frame listeners and how we can process user inputs as well as animation. So one of the main concepts that we want to learn at this point in our work with Ogre 3D is to learn about how Ogre will be able to give us a mechanism so that we will be able to update the states of our engine when certain kinds of events happen. This is basically done through a frame listener in Ogre 3D. A frame listener in Ogre is based off of the observer model, and I'll talk about the observer model in a little bit. In that you would have an interface class that effectively observes, or rather listens to the events that are happening as a part of the operation of our game loop. So whenever an event happens, the observer will be updated with that event, and then we will be able to utilize the observer function to be able to perform certain kinds of tasks. So this is done through a frame listener in Ogre. So basically it's a class, it's an interface class that defines a listener which can be used to receive notifications from frame events. And so what frame events are is in your game loop, whenever your frame buffer performs a swap operation, basically in the rendering phase on your engine, when a complete frame has been completed and rendered, then it will be basically it will be swapped in the frame buffer. So then your the frame buffer gives you what the current being updated frame to the renderer so that you would render it, and takes on the fresh frame to be able to in the frame buffer to be able to perform behind the scenes of rendering. So so when these happen, we call them a frame event, and when one of these frame events happen, and there are basically a couple of them, two very important ones are when the frame starts and when the frame ends, then your frame listener will be updated. So this is an interface that is designed to be called back when such events happen. So what we can do is that we can use this interface to define certain kinds of actions and activities that can be related to frame events. And so to receive these notifications from frame events, here's what we are going to do. We will create a subclass of our frame listener. Then we would override its methods that we would like to customize. And then we will be able to implement our processes, the results of the processes that we want to do. Once this subclass of frame listener has been implemented, we can actually add it by passing it as an instance to the root at frame listener. And that basically, what it does, it kind of attaches the frame listener, our implementation of the frame listener, to the root of our class, and then we'll be able to actually utilize it. We can have as many frame listeners as we want to register, and we can register them for multiple purposes, for the purposes of reading input-output interactions, listening to different kinds of events that are being generated by different kinds of operations. And one of the things that we need to realize, especially because this observer model is based on many-to-many, or rather one-to-many patterns, is that when a frame event occurs, then it will occur for all of the rendering targets, not one per target. So these frame events happen only once. So how does it actually look like, and what would we do with this frame listener? Basically, the frame listener is where we can include our code, as I mentioned, to process for each frame that is being rendered. And it is, as I said, an interface that allows us to modify its interfaces, its member functions, to our liking. And so the two member functions that will be called up and updated whenever the update occurs are the frame started and then a frame ended. The frame started occurs when at the beginning of the rendering of the frame, and then once that is done and before the frame buffer swaps, then you will effectively get the frame ended after the drawing on the screen. And so we can use these two functions to modify them and then include our own functionality and code in these functions. Notice that when the functions are called, a reference to the event, or rather the frame event is going to be passed into these functions. So we would get access to those as well. The frame start and frame events, effectively our member functions within our frame listener must return true in order to keep the game loop going, or rather the rendering loop going. And so if you wanted to exit out of your render loop, simply you would create a condition in one of the members of your frame listener to return false. The moment you return false, then the Ogre render loop will terminate. One of the things that we can use from the frame event reference that is being passed into the frame started and the frame ended is to use the time stamp of since last frame, for example, to indicate the amount of time that has been elapsed since the last frame started happened. And this is going to be useful, especially when you want to actually create time-based rather than frame-based functionality. So for example, to modify the speed at which your objects are moving about and your interactions are are happening. So frame listeners effectively with the frame event reference will enable us to either work and implement mechanisms per frame or mechanisms per time. So it's very, very useful to utilize. Now, in this slide, I'm showing you a very simple example of how a frame listener structure would effectively look like. So basically, as we said, we will create a frame listener class for our example, and we have it inherit from the base frame, and then we would implement a Boolean function for registering the frame started. And then, for example, in this case, if you wanted to look at what we may put in our frame listener, if I wanted to work with the input-output system with the mouse and keyboard, in my frame listener's frame started, I could actually register my keyboard and my mouse and my iOS system, and then capture the keys and the mouse information and utilize those to create the processes that I want to do on the input, and then return true. If I wanted, for example, on the press of the escape key to exit out of my Ogre loop an application, I would basically check to see if the keyboard that I read was escape key, and if it was, then I would basically return false, and so forth. So if you wanted to also perform certain kinds of actions and logic that might occur at the end of your rendering for each frame, you could also implement a function for registering your frame ended, and then utilize the logic in the frame ended scene or rather function as well. So what we are going to do now is we are going to go ahead and create another Ogre project. And in this project, what we are going to do is we are going to control an Ogre entity that would be, for example, a Sinbad mesh. So we're going to set up our application first, just like what we did last time. And then once the application is set, then we are going to go and create a plane for the floor, and then place an Ninja mesh on it, or rather an Ogre mesh, a Sinbad mesh on the floor, and then we are going to overload, or rather create a class for our frame listener, and start working in this frame listener to make the object first move about, time-based and then speed-based, or rather frame-based and then time-based. And then we are going to utilize our frame listener to register our input manager and utilize the keyboard to be able to control our application. Okay, so here we are in our Visual Studio. Then again, I'm really quickly going to go ahead and show you how to set up the project from scratch. But at this point, you should be able to just do it almost without any help. But we're going to go over it. So we're going to first start a project, a new console application, empty console application, and I'm going to call it frame, or rather interactive Ogre project. And we are going to make this an empty application. And then in our application, we are going to add a new source file. And then we are going to have to start working on our C++ directories, properties, linker properties, and then the DLL files, or the binary files. So open up your project properties, and then go to the additional include libraries, and then expand your edit function. And now we're going to have to add a couple of include folders. And the first folder that I'm going to add is going to be my Ogre home VC12, which hosts the environment variable that looks at the path for my Ogre folder. Then I'm going to add the include folder. Then what I'm going to actually do is go and copy my environment variable, include Ogre overlay, I believe it was, and finally boost. So these are my include files. Then I would have to go and add the library files, and those would be the boost library, and then the Ogre VC lib debug. So for that, we're going to go to the linker in the general tab, and then we're going to add Ogre boost lib, and add Ogre lib debug. And those should be my where the libraries for Ogre and for boost are. Then we're going to go to the input tab of the linker property, and then we will add the three dependencies, or the three libraries: Ogre main, overlay, and OIS. And this time we're going to actually use the OIS functions for our object-oriented input system. So Ogre main underscore d.lib, OIS underscore d.lib, and Ogre overlay underscore d.lib. Notice that I'm using the underscore d files because of the debug. And finally, I would have to go and point in the debugging tab, point my working directory, instead of being my project directory, to be Ogre home VC12 /bin /debug. And these are where the DLL files for my Ogre and OIS are. If you didn't want to do that and you wanted to use your Ogre project as working directory, you would have to go and copy the DLL files and paste them in your project folder. If I didn't make any mistake typing or didn't have any typo in here, this is all that needs to be done to set my project up. So set up Ogre Home, rather include libraries, link files, or rather library files, and then your binary DLL files. Now that those are set, let's go in our source and then start our project. So I would have to go and include my example application, and then I have my example application created. I'm going to also use the namespace Ogre, so I don't have to type in Ogre namespace resolution. Then we're going to create my interactive example application, and I'm going to make this to be publicly inherited from example application. And then we are going to create a create scene function for our base application. Then we're going to create our int main function, return 0, and then create an instance of our my interactive application, call it my game, and then my game.go. Now let's run this scene and make sure that we compile and see if it works. Okay, it succeeded. Okay, and it does seem to work. So I had so our project is set up fairly well. So let's go ahead and in our create scene, let's create a new member variable for this class, and private member variable class, and let's call it so it's going to be a scene node pointer, and let's call this our Sinbad node. We're going to see why we used this Sinbad node as a function here. When I'm going to use my frame listener, I would pass this member function when I register my frame listener, so that you will have access to this node from our frame listener to be able to move it around and interact with it. Then we go to our create scene, and we are going to create a plane. So if you remember from last time, we basically create a ground plane, and our ground plane basically takes in a vector 3 unit underscore y as its up vector. We'll move it -10 point down so that we offset it, and that would be the plane. Then we're going to create a mesh plane. So we use the mesh manager from Ogre, get singleton, create plane, and then from the create plane we're going to pass its variables. So plane 01, or rather parameters. So the name of this plane is going to be plane 01. Then we're going to use the resource group manager default group name, pass to it the plane we want to create, so it's going to be group our ground plane that we just created. Then the size of this plane would be 1,500 by 1,500. Number of sections for it, 200 in X and Y. Then we'll set the normal vector to be true, and 5, 5 for tiling of our textures, and we use vector 3 unit underscore z as the up vector for our texture. So this sets up our ground plane as we mentioned. Then we're going to create an entity for this. So entity pointer plane int in scene manager. Create entity ground plane int 01, and its name is plane 01. This will effectively create the entity based off of the ground mesh that we created. Then we're going to add this as the child node, or rather the object of our root. So we create a child for the root scene node and then attach this entity to it. So to do that, if you remember, actually, since I don't want to access this, the entity that, or rather the scene node that holds the ground, I don't want to move it around. I'm not just going to actually create a scene node for it specifically. So we get the root scene node, create child scene node, attach object, and attach it plane int. Now we're going to go and also set the material for our plane entity. So plane int set material name, and material, just like last time, we're going to use example and then beach stones. Examples and then beach stones. So basically, I have a ground plane. I set a mesh based off of the ground plane. Then I attached that mesh to an entity that I created. And then I attached that entity to a child scene node for the root. So now I have my root scene node. I have a child for it, which I don't have access to. I created on the fly, and then I attached object to it, rather the ground object to it. And that then I created the material for my object. Then we're going to go and create a light pointer. Let's call it light. And here we're going to use m scene manager, create light, and then we're going to call this light 01. Then for the light, we're going to set its type as light LT directional, and then we're going to set its direction I'm going to make it go diagonally down, so it's going to be 1 on the x, -1 on the y, and 0 on the z axis. So it's going to be a vector 3, 1, -1, and 0. So this is going to set my light. Then we are going to go ahead and create a camera. So I'm going to go and override the create camera function and set the M camera equal M scene manager create camera. Call it my camera 01. And now that the M camera is created, or rather set, we're going to go and change the M camera, or rather set its position to 100 on the y-axis and 200 on the z-axis, and then set its look at 000 at the origin, and then M camera set near clip distance to be about 5. So if you get too close to the ninja, then it's gonna clip. Okay, let's run this code and see how it works. Okay, this is a very good setup. All right, now let's go ahead and create a node for our Sinbad, and then attach it to our scene. So create a scene node pointer and call it node node 01. Then use this node as the child of the root scene node. So from the scene manager, get root scene node, and then add child our node. Then we'll create an entity for our Sinbad. Call it Sinbad, and this will be effectively from your scene manager, create entity, and so give it the name Sinbad01, and then Sinbad.mesh. Okay, so basically what we have done so far is we created a node, a scene node, and then we gave it the name node01. Then we attached that node to the root scene node. So now we have the address of it. So we actually have a container for our node. And then we created an entity for this node. Let's also go ahead and attach the Sinbad node. Actually, let's do something else. So that node is where the Sinbad object, and maybe if you wanted to have additional objects to it, we can create and we can place in. So what we're going to do is we are going to create a child scene node for the node, and then we use that as the Sinbad node, which we already declared up here as a private function, private member variable. So let's do the Sinbad node, and let's make this Sinbad node to be a child of the node. So go and create child scene node, and then call this my Sinbad node. Then we're going to scale this Sinbad node to, let's say, 5. and then we'll position it to 0, and then 4, and then 0, and then attach the Sinbad entity to it. Attach object Sinbad, which is our entity. Now let's compile and run this code. Oh, yeah, let's move the Sinbad to, I think, about 10 on the y-axis. Okay, 10 wasn't big enough. 15. Okay, looks like, yep, Sinbad's feet are on the ground. Yep, it is good. It should work. Okay, so next we're going to go and create a frame listener from this point on, and we'll make the frame listener to actually make the Sinbad to move, both by frame and by time. Okay, so now is the time for us to go ahead and start our frame listener. As I said earlier, your frame listener is basically an interface class that will be updated as an observer when certain kinds of things happen. And in our case, for example, when a frame is being rendered, or it has finished rendering, and the drawing on the scene, the frame started and frame end events are going to be effectively observed and updated. So let's go ahead and start our frame listener class. So it's basically a class, and so I'm going to call this my frame listener, and I'm going to make this inherit from the frame listener. We're going to create a member variable, a private member variable for in our frame listener of the type scene node. So make this a private member variable scene node pointer, and we're going to call this node. Now this node is going to be utilized when we are going to basically perform functions on it. Now we're going to build the constructor for our frame listener. This frame listener will have actually two constructors: a default constructor, which then basically sets it at null, or an overridden constructor that takes in a scene node from the application that creates it and attaches it. So my frame listener scene node pointer node that is passed to it, and here we're going to make our member variable node to be set as the node that was passed to us. Okay, so this is the shell for our frame listener. I created my frame listener class, which is inherited from the frame listener. It has a member variable node underscore node, which is the frame listener's node, and it's a scene pointer. And then it also has a constructor, and the constructor takes in a scene node, and it sets the node that is passed to it to the node that as its main member variable. And that's the only constructor that we have. Now, what we are going to do is we are going to go to our base application here, or rather my interactive application, and then we're going to create a frame listener pointer. So frame listener pointer, and then let's call it my listener Okay, and so now that I have my frame listener pointer in my base application, or rather my class application, I'm going to have to go and create a constructor and deconstructor in this class, because this class now actually does contain a pointer and to a frame listener. I would have to create a constructor that takes in and sets this frame listener as null, so that later on I can access it, and then a destructor that then deletes this frame listener. So let's go and create a my interactive application constructor, and this basically takes my listener and sets it to null. And then a destructor for my interactive example, that if my listener existed, then it's going to delete my listener. So I created a constructor and a deconstructor for it. Obviously, I forgot the parentheses. Now that I have let's spell all these listeners and my listener. Yeah, although the spelling doesn't matter. I just want to make sure that the spelling of my variable are correct. So then again, let's go over, let's see what happened, what I did here. I created a frame listener pointer. I called it my listener. Then what I'm going to do is in the constructor of my interactive application, I'm going to set it to null. And then in destructor, if it is not null, then I'm going to delete it. Now that my constructor and deconstructor, or rather destructor, are created, we will have to go and create a function called create frame listener. So we're going to create frame listener. And in this create frame listener, what we will have to do is we'll have to register our frame listener, basically create a new frame listener, which basically is going to be calling the constructor of this frame listener and then attach to it. So my member variable was the listener, or rather my listener, and we're going to create it as a new frame listener, and we are going to pass to it the Sinbad node as the scene node of the object for which we want the listener to be applied. And now that this listener has been created, we're going to attach it to the mroot as add frame listener, which will basically take in the pointer to my listener. So then again, let's go over these steps to show you how it worked. So what we did is we created a frame listener class, and this frame listener class has a member variable, private member variable underscore node, and its constructor takes a node from the application that creates it and then sets its node to the node of the application that created it. We created a frame listener pointer in our own application and created a function called create frame listener that basically creates the listener, called my listener here, by calling the constructor of the frame listener that we just created down here and passing a Sinbad node to it. Once this frame listener is created, we are going to add the frame listener to the root of our application. So mroot add frame listener, this is how you register your frame listener. Now, since this is a pointer, the frame listener, my listener that we created, is a pointer. So notice up here we have a frame listener pointer. Then we will have to maintain our memory management. So we would have to create an interactive application constructor that sets the frame listener to null. And then in the destructor, if the frame listener was created by create frame listener functionality, then we would have to delete it. So that's our basically our memory management right there. Okay, so this frame listener basically currently is not doing much of anything. What we are going to do is now go ahead and for its frame started function, we're going to use it to be able to translate the node. So if you remember the frame started function we talked about, we're going to override this frame started function. And the frame started function also takes in a constant frame event. And what we are going to do is when the frame started, we're going to translate our node by a value of vector 3. And we're going to move it by 0.1 on the x-axis, 0 on the y-axis, and 0 on the z-axis. So effectively, whenever this frame listener is registered to our application, whenever the frames are being rendered, we'll take wherever the location of the ogre is and move it 0.1 unit to the right. And then the next frame, we're going to move and translate 1 unit to the right. And in the next frame, we're going to translate 1 unit to the right. So now let's compile and see what happens with this application. Okay, we have an error. Let's see what our error is. Yeah, I think, yep, my error here is because I defined my frame listener before my after my application, and obviously I won't have access to it. So I moved. So now I moved the frame listener, or rather my frame listener, on top. When you're writing your code and you have header files and source files, then it doesn't matter where your objects are defined and your classes are defined. In this case, it does matter. Oh, and we needed to return true in our frame started event. Okay, so obviously the object moved, as you saw real quick. And we can't really close our application anymore. And it is because when I overrode my frame listener, now I'm not using the base applications frame listener, which basically implemented the escape key to close out and the movement for the mouse and my camera. So now to close the application, you would have to force close it, actually. And I'm going to run one more time. And you see that the object, the ogre mesh, really quickly moves about to the right. It just gets out of the scene, and we won't be able to actually move the camera anymore. It's because our frame listener, as I mentioned, we overrode the frame listener, and now we won't be able to actually access the contents of our original frame listener. I'm gonna wrap up this this video at this point. I think this showed the implementation of our base application, and we went over our frame listener function, and rather our own customized frame listener class that we used. So basically, we created my frame listener class based off of the base application's frame listener. We created a node for it. And in the constructor of this frame listener, we passed the node for which we want to create the frame listener. And then we also created, or rather used the frame started function to translate the node that we passed or attached to it to translate it 0-point unit to the right, so from one frame to another frame. And as you notice, there's one slight issue with this, and that is it is per frame update. And it's not really good because it would depend on the platform and the computer that you're using, since every frame you're translating your object. So if 2 frames take a long time to operate, or a small time to operate, the speed would be different for your application. So the problem in this case is that we are per frame updating our scene, which isn't really a good thing to do. So we want this to be time-based rather than frame-based. And this the event function that we have here, the event variable reference that we have, it would enable us to actually listen to the time frames or the time that it took between 2 frames to render and adjust our movement accordingly. Now, once this frame listener was created, we created a pointer to it, once we typed or created this class of frame listener, then we went in our base application, and then we created a pointer frame listener. Then we created a create frame listener function that basically we overrode it, and then we created the frame listener, our frame listener, to be a member or an instance of the class myFrameListener. And then we also passed the node Sinbad to it. And then we attached our listener to the root. So we added the myListener to the root. Since we manually created this frame listener pointer, we would have to deconstruct it in the destructor of our interactive application class. So if it was created as a part of this class, then we also go ahead, once the class is destructed, we will delete the frame listener accordingly. So this is an overview of how a frame listener can be created and can be used. In the next video, we're going to talk about the differences between time-based and frame-based movement and events. And when we get to that, then we'll see how we can use the input-output systems to effectively create an input manager to listen to the keyboard and mouse events. So until the next video, I'll let you think about this video and work on your frame listener and get used to this application.